Hi there, guys. Hope you're having a great day. Today we have something exciting planned. We are going to be learning how to model chemical equations. We're going to be looking at two chemical equations, one for cellular respiration and the other for photosynthesis. First, we're going to take a look at cellular respiration. Here I have the balanced chemical equation. It's a little different than what we've seen in the past because it's now balanced, meaning what's on the left-hand side, the reactants, are going to equal what is on the right-hand side, our products. The main difference is now we have coefficients in front of some of our molecules. Take our O2 or oxygen molecule, for example. There's a number 6 in front of it. That's just showing that there are going to be 6 O2 molecules in this chemical equation. Let's take a look at the other coefficients that we have. We have the 6 in front of our O2, CO2, and H2O molecules. Make sure to multiply correctly. In order to model this, we're going to use some beans to represent our different elements. Just a reminder that C is the symbol for carbon, O is the symbol for oxygen, and H is our symbol for hydrogen. As you can see, I'm using a black bean for carbon, a red bean for oxygen, and a lentil to represent hydrogen. I'm going to put this red arrow down to show that a reaction is occurring. I am also going to add some addition signs for the ease of your viewing. So the first thing that I need to make is 6 O2 molecules, or 6 oxygen molecules. I'm going to grab 2 beans for oxygen and make 6 pairs of them. We all know that the next molecule is also known as glucose. 6 carbons, 12 hydrogens, and 6 oxygens together. Both our 6O2 molecules and glucose are reactants, which will form together to make our products. Our oxygen molecules are going to take one of the carbons from glucose to produce CO2. There are going to be 6 CO2 molecules made within this balanced chemical equation. Left over, we have 12 hydrogen molecules and 6 oxygen molecules. They can reform into 6 H2O molecules, or, as we call it in our everyday lives, water. Now I just have to point out that here I wasn't clumping them together, and just make sure that your beans are touching to represent that they are part of the same molecule. The last product of cellular respiration is the energy that organisms need to live. Make sure you act this out dramatically. Now that we've modeled cellular respiration, we're going to take a look at photosynthesis, which we know is just the reverse of cellular respiration. So I can move our products over to our reactant side. As we can see, we need 6 CO2 molecules, so moving those on over, and we need 6 H2O molecules. As we know, photosynthesis doesn't occur without sun energy. Make sure you dramatize this. Just like our last equation, our arrow is showing that a reaction is occurring. Our CO2 molecules are going to break apart to form 6 oxygen molecules. Make sure to take a look at that coefficient. Now our leftover, we have 6 carbon, 12 hydrogens, and 6 oxygens that are going to form our glucose molecule. As we can see, this is a cyclical cycle between cellular respiration and photosynthesis.